Hello everyone. In this part we will be discussing the question number 4, 5 and 6. So the question number 4 is a curve has equation y is equal to x square minus 2x minus 3. A point is moving along the curve in such a way that at P the y coordinate is increasing at 4 units per second and the x coordinate is increasing at 6 units per second, and we need to find the x coordinate of P. So what are the given things? We can rewrite it as d at P. We can write at P dy over dt. Dy over dt is 4 and dx over dt is 6 units per second. So and what is given? Y is given as x square minus 2x minus 3. So we can see from here we require dy over dx, and if we require dy over dx, we can use the chain rule because we have dy over dt and dx over dt. So from here dy over dx is equal to 2x minus 2, and dy over dx can be written as dy over dt by dx over dt by chain rule, and hence it become 4 over 6 or 2 over 3. Now after substituting this value in this ty over dx, we will get 2x minus 2 is equal to 2 over 3, or 2x is equal to 2 over 3 plus 2, and hence we can solve and you will get it is as 2 3 is 6 plus 2 8 over 3, and hence x become 4 by 3. And since we are doing all the things at P, so x coordinate of P is 4 by 3. That is the answer. I hope it is clear. Now the question number 5. Question number 5 is solve the equation this for theta in between 0 and 90 degree. So we can see there are theta and tan theta and sin theta. First of all, we will do cross multiplication so that we can get everything in a linear form. So we can rewrite it as tan theta plus 3 sin theta plus 2 is equal to 2 tan theta minus 2 3 is 6 sin theta plus 2, and you can see these two are constants, so can be cancelled, and here we can rewrite it as I am transferring everything to one side. It would be 2 tan theta minus tan theta. I took this tan theta to the other side, and minus 6 sin theta minus 3 sin theta, and then it become is equal to 0. This 0 was coming here, but I have written other side, and it can be solved further, and you can will get tan theta minus 9 sin theta is equal to 0. So now we know that tan theta is sin theta over cos theta, so it can be written as sin theta over cos theta minus 9 sin theta is equal to 0. So from here we can take sin theta common, and we'll be left with 1 over cos theta minus 9 is equal to 0. So from here we'll get two equations. The product is 0, so they individually they should be 0, and hence sin theta is equal to 0, or 1 upon cos theta minus 9 is equal to 0. So from here we can say directly that theta is going to be either 0 degree or 180 degree, which is not possible in this case or not applicable in this case because theta is in between 0 and 90. And from here we can get cos theta. I took this minus 9 over there, that become 9, and hence cos theta become 1 over 9, and this will give you theta as cos inverse 1 over 9, and this value is 83.6 degree, and next value will be 360 minus theta, which is of course not in the range. So the answer is, the solution, you can say solution is 0 degree and 83.6 degree. I hope it is clear. So here is the question number 6. The question number 6 is the coefficient of 1 over x in the expansion of this is 720. So in order to find the coefficient of 1 over x, we need to decide what is going to be how you find the power of x here. And for that we already know, if we have a plus b raised to the power n, then in that case that r plus 1th term is given by NCR a raised to the power n minus r and b raised to the power r. So if we relate here, we can see a as 2x and b as a over x square. So r plus 1th term here become 5cr 2x raised to the power 5 minus r and a over x square to the power r. We can rewrite it as 5cr and 2 raised to the power 5 minus r and a raised to the power r. I am taking x at the same place, and then it would become x raised to the power 5 minus r minus 2r, because here it is x square in the denominator. Or finally we can rewrite it as 5cr 2 raised to the power 5 minus r, a raised to the power r and x raised to the power 5 minus 3r. So for 1 over x, we can see directly that 5 minus 3r should be minus 1. 5 minus 3r should be minus 1, and hence from here we can get 5 plus 1 is equal to 3r, or r will be 2. R is 2. So this implies third term 5c2 2 raised to the power 5 minus 2 a raised to the power 2 and x raised to the power minus 1. Or we know that 5c2 is 5 factorial upon 2 factorial into 5 minus 2, that is 3 factorial, and hence it is only 10. 10 into 2 raised to the power 3 a square upon x. Hence according to the question, since the coefficient of 1 over x is 720, it means 720 should be equal to 8 into 10 80 a square. From here we get a square as 9, and hence a is equal to plus minus 3, and there are it's given that possible values of constant a, it can be plus 3 or minus 3. So let's have the second part of it. Hence find the coefficient of 1 over x to the power 7. So if we see again, for 1 over x to the power 7, 5 minus 3r should be minus 7, or 5 plus 7 is equal to 3r, so r become 4. So now r is 4, so r plus 1, fifth term we can get from here. Fifth term will be 5 NCR, that is 5c4, and it was 2 raised to the power 5 minus 4 and a raised to the power 4 and x to the power minus 7, and hence we can solve it. It is 5c4 is 5 into 2 raised to the power 1 is 2, and hence a raised to the power 4, a raised to the power 4, it is plus minus 3 raised to the power 4 and over x to the power 7. So it becomes 10 into 3 raised to the power 4 is 3 into 3 9, 3 is 27, 3 is 81, it is 81 over x to the power 7, and this will give you the coefficient of 1 over x to the power 7 is 810. I hope it is clear. We will discuss rest of the question in the next video. Thank you so much.